In this video, we will talk about some things to keep in mind when modeling analytical and physical elements, specifically about the result and design differences. Here I have two similar models showing some physical members in the long span and analytical members in the short span. Now let's check at the section properties. I have defined two, one for the short members, another for the long continuous members. We have same material for both models, fixed supports at the edges. Taking a look at the loads, I have defined one load case, a distributed load, taking into consideration gravitational factors. And if I display this load, I can see that for short members I have a minus 20 kilonewton load, and for the long members, the continuous members, I have a partially load that goes from 0 to minus 40. If I go to settings and check the preferences, I would suggest to always have this option checked, always preserve loads during element subdivision. I click OK. Now if I go back to the geometry window, I will convert these two models into analytical elements to see what happened with my loads during this load subdivision process. And I can do it if I go to Edit, Analytical Model, Convert to Analytical Model. It's letting me know that the physical elements will be deleted, so I click yes, and now I have only analytical elements. Let's take a look at the loads and what happened. Maybe you see this as this load has been splitted, but basically these are the same values as we had before. Now I'm going back and I'm gonna make continuous one of these models. So in order to make continuous, I need to have this option. If I go to settings, preferences, this option selected, model using physical elements, and if I turn this option on, I can use this tool to make continuous elements. And I just need to find my first and second point to convert from analytical to physical. Now I can proceed to analyze this model for linear static analysis. And I see it comes with a clean solution. Let me turn this option off, and we can check the results such as deflection. Here we have physical elements, so if I right click and go to properties, the set deflections, you can see I have a maximum minus 5 millimeters. This is for the whole physical element. Now let's check one of these short elements similar to these. Remember, these have the same load being applied. If I go to properties, set deflection, you will see that it starts and ends at 0 because this is the local deflection diagram, and it's showing the deflection between the start and end joints according to the deflected positions of those joints. But I'm interested in the global, so I'm going to click global deflections, and now you can see that has the shape we're expecting, ending at minus 2, almost minus 3 millimeters right here. You can also display the set deflections, and we can see we almost have the minus 3 millimeters here. Similarly, I can go to the shear diagrams for the Z axis shear, check some of these results. Let's say this element right here, I can see that goes from 178 to 106 if I close and access the same member but continuous this time. I see I have the same values right here. Moving on, after you review your results, you can proceed and go to STIL. And here, of course, you can start selecting all your members. Here is our long section, and you can see how it looks like compared to the other model, where it's broken up into several segments. So if I perform a code check for my load case, I will see that the utilization ratios that I'm receiving is on the verge, so demand is almost same as the capacity. That's why it's showing yellow. And in this case it's showing a low value, and this is because and if we take a closer look, if we right click and go to code details, and if we zoom in, we can see the values for lateral torsion is on the verge of failure, where the length is 8 meters, and of course it's being used in the equations according to this clause. So if I go back, select this one for example, go to code details, in this case it's giving me a low value because of the length of this member. Thank you for watching, and for more tutorial videos please subscribe to our YouTube channel.